For decades, scientists believed modern humans evolved with one distinctive body type: slender, graceful, lightweight. A unique skeletal blueprint that separated us from our stockier ancestors like Neanderthals. The theory seemed settled, the textbooks agreed. Then researchers examined Ötzi the Iceman's ribcage using advanced 3D scanning, and what they discovered completely overturned this fundamental assumption about human evolution. Ötzi the Iceman was discovered in 1991 in the Ötztal Alps on the border between Austria and Italy by German hikers. Ever since, he has become the subject of countless scientific studies, transforming into arguably the most scrutinized human being in history. These investigations have revealed an extraordinary portrait of life 5,300 years ago during the Copper Age. His 61 tattoos, arranged in lines and crosses across his lower back, legs, and wrists, are believed to have functioned as a primitive form of acupuncture, likely intended to alleviate joint pain or arthritis. His clothing demonstrated masterful ancient craftsmanship: leather leggings, a loincloth, a goatskin coat stitched from hides of different sheep and goats, a bearskin cap, and shoes insulated with grass for warmth, all meticulously designed to provide protection against brutal alpine cold. Analysis of his stomach contents revealed his final meal: ibex, red deer, and einkorn wheat, an early domesticated grain, suggesting a diet bridging traditional hunter-gatherer lifestyles with emerging agricultural practices. His genome showed he was lactose intolerant, meaning he couldn't digest dairy products, possessed a genetic predisposition toward cardiovascular disease, and carried ancestry tied to Anatolian farmers who migrated to Europe around 7000 BC. His collection of tools and weapons revealed he was an experienced outdoorsman. He carried a copper axe and a quiver containing 14 arrows, though only 2 were finished and ready to fire. He also possessed a flint-bladed knife with an ashwood handle, a yew longbow that remained unfinished, and 2 birch bark containers. Most hauntingly, Ötzi's death was no accident. An arrowhead lodged in his left shoulder revealed he met a violent end. Just when it appeared the Iceman had surrendered all his secrets, a new revelation opened in his story, one that fundamentally challenges our understanding of human evolution. For decades, scientists assumed that the slender, graceful ribcage of modern humans was a derived or unique characteristic that distinguished us from our more robust predecessors such as the stocky Neanderthals or ancient Homo erectus. The ribcage, or thorax, is the bony structure formed by ribs, sternum, and spine, protecting the heart and lungs while enabling breathing and supporting the upper body. This interpretation, rooted in early reconstructions of fossils like the Nario-Kotome boy, a 1.5 million-year-old Homo erectus skeleton from Kenya, proposed that Homo sapiens evolved a lightweight, gracile body plan, possibly to enhance efficient locomotion or maintain upright posture for long-distance travel. But a groundbreaking 2025 study in communications biology has completely dismantled this narrative, with Ötzi's ribcage at the center of a paradigm-shifting discovery. The researchers reconstructed Ötzi's ribcage using advanced 3D digital modeling and geometric morphometrics, a scientific method that quantifies the size and shape of anatomical structures by placing precise landmarks on digital scans and analyzing their spatial relationships. Reconstructing. Ötzi's ribcage proved extraordinarily complex. The ice that preserved his body for 5,300 years also distorted his ribs, bending them dorso-ventrally toward the back and belly due to his prone position within the glacier. The result was a digital model of Ötzi's ribcage, larger and more barrel-chested than those of many modern humans, with a wider lower chest and narrower upper chest, yet retaining the globular shape characteristic of Homo sapiens. This ambiguous thorax, as the researchers described it, was neither fully slender nor massively robust, but rather a unique adaptation for Ötzi's life of seasonal alpine transhumance. Ötzi lived around 3,300 BC during the Chalcolithic period, a transitional era when Europe witnessed the rise of copper tools alongside stone implements. His lifestyle involved seasonal alpine transhumance, a practice where populations move between lowlands and highlands with changing seasons. In spring and summer, Ötzi likely traveled to high alpine areas above 3,200 meters to hunt or herd, retreating to milder valleys during winter to escape harsh cold. This demanding lifestyle required a body capable of enduring thin air, where oxygen levels drop due to lower atmospheric pressure, freezing temperatures that could plummet below -10 degrees Celsius, and long treks carrying heavy loads, including his copper axe, flint dagger, quiver of 14 arrows, and birch bark containers for carrying supplies. His ribcage, with its larger size and barrel-like design, enhanced lung capacity to support deeper breathing in the oxygen-scarce air of the Alps, where physical exertion demands substantially more oxygen. It also helped retain body heat during frigid alpine nights, aligning with Bergman's rule, an ecological principle stating that animals in colder climates tend toward larger body sizes to minimize heat loss by reducing surface area relative to volume. Yet its globular shape, wider at the base and narrower at the top, unlike the flatter, wider thoraxes of Neanderthals, ensured metabolic efficiency in warmer lowlands, where excessive bulk could lead to overheating. This made Ötzi's ribcage a versatile compromise for a man who existed between two environmental worlds. Although Ötzi's unique ribcage helped him survive the harsh alpine environment, unfortunately for him, it could not prevent his violent end. Forensic evidence paints a grim picture. An arrow struck his left shoulder, severing the subclavian artery. Although recent studies have shown the blood loss was minimal and likely not immediately fatal, he fell, became incapacitated, and froze to death. But, in a twist of fate, his violent end led to remarkable preservation of his body, ultimately helping scientists uncover a new evolutionary theory that challenges the idea of a single uniform human body type. To support this theory, researchers made comparisons to other ancient individuals which revealed a spectrum of Homo sapiens adaptations. Nazlet Khader, 38,000 years old from Egypt, had a small cylindrical ribcage suited for heat dissipation in an arid climate. Ohalo, 23,000 years old from Israel, also possessed a slender cylindrical thorax adapted for foraging in the temperate Levant. Dolny Vestonets, 30,000 years old from the Czech Republic, possessed a massive ribcage nearly as large as Neanderthals, built for heat retention during the last glacial maximum. The Neanderthals Kebra, 2, 60,000 years old, and Shanidar, 3, 50,000 years old, had stocky flat thoraxes for cold climates, while the Nerio-Kodame boy, a 1.5 million-year-old Homo erectus, had a robust juvenile ribcage. These comparisons demonstrate that Homo sapiens' ribcage morphology varies substantially with climate, unlike the uniformly slender body plan once assumed, with Ötzi's intermediate thorax reflecting his. Unique alpine adaptation. The findings from this study fundamentally change how we understand human evolution. Scientists previously believed all Homo sapiens evolved with a slim body shape, but Ötzi's ribcage proves that's incorrect. His body, along with other ancient fossils, shows that human ribcages developed in different shapes and sizes, depending on factors including climate, lifestyle, and ancestry. The story of Ötzi, which began as a curious tale of a frozen mummy, has evolved into a profound lesson in human evolution. His story, and those of other ancient individuals studied alongside him, tells us there is no single blueprint for a Homo sapiens body. Our species has always been a mosaic of forms shaped by diverse climates and lifestyles we've encountered throughout our long history. Thanks for watching. If you enjoyed this deep dive into how genetics is rewriting history, make sure to like and subscribe so you don't miss the next discovery. This is Hidden Strata,